मैं डॉक्टर गुलाब फलारी, एसोसिएट प्रोफेसर, डिपार्टमेंट ऑफ इकोनॉमिक्स, जे कॉलेज आरा। आज के मेरे लेक्चर का टॉपिक है द सिंपल लीनियर रिग्रेशन मॉडल। We know that the regression analysis is a powerful tool in the field of statistical analysis. In predicting the value of one variable given the value of another variables when these two variables are related to each other. For example, here two variables are given: fertilizer used and crop yield on various plots of land. Now fertilizer used denoted by X, known as independent variable here, and crop yield on various plots of land denoted by Y, known as dependent variable. Now the general process of predicting the value of one variable Y on the basis of the known value of the other variable X is known as regression analysis. अब हम सरलता के लिए इसे तीन भागों में बांटकर यहां पर स्टडी कर रहे हैं। सबसे पहले किसी भी फंक्शन का फंक्शंस इन डिटरमिनिस्टिक फॉर्म, फंक्शन इन स्टोकेस्टिक फॉर्म and the method of providing least square, that is OLS method. तो सबसे पहले फंक्शन इन डिटरमिनिस्टिक फॉर्म के बारे में जानना है। Assuming that Y, P and all other determinants of demand are constant, अगर constant है, we can express the quantity demanded, that is denoted by Q, of any commodity as a function of the price P. Then this may be put in the form Q equal to function of P. Similarly, we are familiar with the other function in bracket with different assumptions here. We assume here different assumptions such as function conjunction function C equal to function of Y here is income, supply function S equal to function of P here is price, and production function Q equal to function of X1 and X2. X1 and X2 here are two production factors of production reduction. Now the functional relation may be linear, quadratic, logarithmic, exponential or hyperbolic. This functions. A linear function, quadratic function, logarithmic functions, exponential functions and hyperbolic functions. Now a linear demand function in deterministic form can be written as Q equal to function of P. An equation of this function alpha plus beta x, where alpha greater than 0, beta less than 0. And in particular, suppose that Q equal to 100 minus 5P, when P equal to 10, then Q equal to 50. Suppose that when P equal to 15, then Q equal to 25, etc. But such as an exact and deterministic relation between P and Q is never true in the real world. Now come to the function in stochastic form. The deterministic behavior of the relationship breaks down when ceteris paribus condition is relaxed. Ceteris paribus is a phrase means if other things remaining the same. Then we therefore rewrite the demand function as q equal to alpha plus beta x plus u, or in particular q equal to 100 minus 5 plus u. Now where u as random disturbance, since it disturbs otherwise the deterministic relations, या u के कारण ही या डिटर्मिनिस्टिक रिलेशनशिप बिटवीन टू वेरिएबल्स नहीं हो पाता है, और जब हम इस u को ऐड करते हैं then we get the function in stochastic form. Now the simplest form of stochastic relation between two variables x and y is called simple linear regression model. This is important. It is called simple linear regression model and is given by yi equal to alpha plus beta xi plus ui. For I equal to here 1, 2, dash 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 and number of items, where ui here equal to stochastic disturbances. The stochastic nature of the regression model implies that for every value of x, there is a whole probability distribution of x of value of y. Now come to the method of ordinary least squares, that is known as ordinary least square methods. Let alpha hat and beta hat be the estimated values of alpha and beta. The estimated relationship becomes y hat I equal to alpha hat plus beta hat xi and ei residual yi minus y hat I, which is the residual term shows the difference between the observed and estimated relationship. Now the method of least square consists in finding out the value of alpha hat and beta hat, for which sigma ei square is minimum. This condition must be fulfilled in case of ordinary least square methods. This means that we have to minimize sigma ei square equal to sigma bracket में yi minus y hat I का whole square equal to sigma yi minus alpha hat minus beta hat xi का whole square, through the choice of alpha hat and beta hat. Now come to the examples here. The following table includes the price and quantity demanded of the product of a monopolist over a 6 years, suppose that. And the year is given in 2010, 11, 12, 13, 14, 15. And quantity demanded in thousands 834,780 and price in 100 rupees 243135. These are the given one, and we will have to estimate here by applying ordinary least square methods the estimated demand function, assuming a linear demand function. First we will have to find. Next, estimate the average elasticity of demand. And next we will have to find estimate the elasticity of demand at the price fall at a particular point, and also finally forecast the level of demand if price rises to 5. Now let us calculate all these. Now let yi equal to alpha plus beta xi for I equal to 1 to 6 be the linear demand function. Now the given data, we should plot all the data in this form: year 2010, 11, 12, 13, 14, 15, and here is 6, quantity 834780, price xi 243135. Now we will have to find sigma y equal to 30 and sigma xi equal to 80. For finding y mean, that is 5, and x mean, that is 3. Now take deviation from y mean and x mean. yi equal to yi minus y mean given is here is 5, then 8 minus 5, 3, minus 2, minus 1, 2, 3, 5, and sigma yi equal to 0. Similarly, given x mean 3, then xi equal to xi minus x mean minus 1, 1, 0, minus 2, 0, 2. This is also 0 here. And we will have to multiply xi and yi. Minus 3, minus 2, 0, minus 4, 0, minus 10 to get sigma xi yi, that is minus 19. Now sigma xi whole square 110,404 and sigma xi ka whole square equal to 10. Now we will have to find here the linear demand function. Now beta hat equal to sigma xi yi divided by sigma xi ka whole square, and the given sigma xi yi equal to minus 19 divided by sigma xi ka whole square is 10. Here is 10. This one is value of estimated beta is minus 1.9. Now alpha hat equal to y mean minus beta x mean, and y mean is 5 minus beta minus 1.19, and x mean here is 3. We get this one. Here in this case, both alpha hat equal to 10.7, that is greater than 0, and beta hat and equal to minus 1.9 less than 0. It shows that there is an inverse relationship between price and quantity demanded. Now the estimated demand function may be written as y equal to alpha hat plus beta hat x, that is 10.7 minus 1.9x This is the estimated demand function. Now we will have to find here average elasticity of demand. And the formula for finding average elasticity of demand is beta estimated into x mean divided by y mean. Now beta estimated minus 1.9 into x mean is 3 and y mean 5. That is this one. And in modulus form, ignoring minus sign, we get the positive one, 1.14 greater than 1, shows an elastic demand. Now we will have to find here elasticity of demand at a particular point x equal to 4. This is the estimated demand function. If x equal to 4, then y equal to 7.09. And the formula for calculating elasticity of demand for a particular point is x by y into differentiation of y estimated with respect to x. X here is price. X here is price. Now x is given, x is 4 and y value of 7.09, and when we differentiate this function and with respect to x, we get this one. Now after solving this one, we get finally in modulus form the price elasticity of demand 1.071 greater than 1. And finally we will have to forecast the demand if x equal to 5. Now the y hat equal to 10 minus 10.7 minus 1.9x, when x equal to 4, y equal to 7.09. And if x increases from 4 to 5, then y becomes 1.2. It means that if price increases from 4 to 5, demand decreases from 7.09 to 1.2. That's all.